right, friends, let's look at notes 3.03. You are going to take care of the warm-up yourself. That's why it's a warm-up. It's for you to test out and try on your own. Get your brain moving and grooving. Don't forget to get those done and to follow along because you are going to be putting these in your Algebra 1 folder. Again, the copy of these notes should be in your WAG. If not, send me an email and I will send them to you. Alright, but let's get into what we're going to learn today. The attributes of a linear function. So it gives you a linear function, it puts it on a graph for you. As you can see, it's already labeled it. We're going to be naming these attributes. So let's look at this first one. It says the blank is the point at which the line intersects the y-axis. Well, if you look at your graph, your y-axis is your vertical line, right? Your vertical line. Your x-axis is your horizontal line. So if I'm looking at the graph, let's find where it crosses on that y-axis. And it looks like it's right here. What do we call that? We call it the y-intercept. So the y-intercept is the point at which the line intersects on the y-axis. And if you'll look, this y-intercept is 4. Now, let's look at this next one. Okay. It says, I'm going to use a different color, the blank is the point at which the line intersects on the x-axis. Remember, this is your x-axis, okay? So, let's go and find that. It's right here. And what do we call that? Well, look, there's two different names here. We can call it the x-intercept, right? So the x-intercept is where it crosses it on the on the x-axis. But what else can we call it? We can also call it the 0. So the 0 and the x-intercept are the same value. Okay, so in this case, the x-intercept is 2 and the 0 is 2. And the reason it's called that is because it's the x value that results when the y value is 0. So when you put 0 into the function, you will get 2. Alright, and then that last one, the blank is the steepness of the line, right? If I'm going down a hill, it's however steep, right? It's going like this. What else would we call that if it's found by doing the rise over the run? What's that called? The slope, exactly. The slope is the steepness of the line. It is found by doing the rise over the run. And we could easily figure out what the slope of this is, right? By doing rise over run. How far up did it go? How far over did it go? Now on this one, we don't have to answer it on that one, but you will here in a little bit. So just keep that in mind. Remember that. All right, let's look at these examples here. I actually am going to have you find these examples on your own, okay? If you look at this first one, right, just remember your x-axis is here, your y-axis is here, and so you're looking, where does it cross on the y-axis? Where does it cross on the x-axis? And what is the rise over the run? Right? On that one I was short. Let's see. If I were to do the rise over run for this one, I go 1, 2, 3. And so my rise is 3. Let's see how far over it goes. 1, 2, 3, 4, 5, 6. Now, 3 over 6 is the rise over the run, but I could simplify this, correct? What would 3 over 6 simplify to? What could they both easily be divided by? 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay? Alright, you're going to do those 3 examples on your own. Okay? Let's keep looking. Alright, on the back page, it wants to give you real world situations, okay? So the graph above shows the relationship between the numbers of miles a truck is from its destination and the number of hours the truck has been driven. So you're still figuring out all of the same things, but now it's using real world terminology. So if I look at this first one, it says, what is the rate of change of the distance driven with respect to the time driven? Don't let that verbiage get you confused. Remember, rate of change means what? It means slope. And so once again, we can do the rise over the run. Okay? Now, if we were to do the rise over the run, we could figure that out easy. Or we can put two sets of coordinates into Desmos to also figure out that slope. You could do it either way. Now, these are pretty big numbers, so it might be difficult to do it this way. But you have Desmos as an option, right? If I were to do the rise over the run, though, let's see. So if I'm here at 4, okay, I am going to rise 1, 2, 3, 4, 5, 6, 7, 8, except what did I do wrong? We're not going by 8, we're going by 20s. So 20, 40, 60, 80, 100, 120, 140, 160 is my rise. And then I went over 1, 2, 3, 4. So 160 divided by 4. What is my rate of change there? If I were to simplify that, if I divided both of those things by 4, I would get 40 over 1, or just 40, right? Because anything divided by 1 is itself. All right, let's keep looking. What is the y-intercept of the function, and what does it represent? Now remember, the y-intercept is where it crosses on the y-axis. So remember, your y-axis is your vertical. Where does the line stop on your y-axis? Right here at 160. But 160 what? Miles. 160 miles. Now the x-intercept is where it crosses on the x-axis, which is your horizontal. Well, where it crosses on the x-axis is right here at 4. But what does this represent? 4 hours. That last question, what is the 0 of the function? Well, remember, the x-intercept and the 0 are the same thing. So if 4 hours is your x-intercept, your 0 is also 4. Alright, and you're going to try that last one on your own. Remember, you're using this graph here, to answer these questions.